donkey cart built as part of this project has been ordered online from donkeycart.com. So it can their documentation teaches us to how to build the car, how we can assemble the different parts, and how we can use the camera to actually attach with the Raspberry Pi. Right now I've finished building the base of the car following the documentation. I've connected the Raspberry Pi with the car, and I've added the base with the camera holder right here, and the camera is right here. It's connected to the Raspberry Pi, and this is all powered by power bank. This Python module named as manage.py is actually creating the server and allows control of the car. As you can see here, I've placed the camera inside the holder, and this will be pointing outwards from the car. Right now, I've coated the microbit with a cover on top of it so that it shows the current accelerometer readings on the x-axis. So when it's stable, it shows values which are 1, 2, or even 3. But if I'm moving it around, that's when the values change. The Raspberry Pi is installed with OpenCV and TensorFlow Lite from a repository. Libraries have been used, which has pre-trained car detector algorithms, and it has a pre-trained face detector algorithm, and this was used. So they have their models already built, and they are built on a range of scenarios. We can see that I have used the ARM32 for Python version in the Raspberry Pi. As we can see, these are the pictures that the model was trained on, and this is pretty much real life scenario. So therefore, it can detect all road cars pretty much. That includes oncoming traffic, such as this one, and any parked cars, and it can even detect cars from sideways. The model used in this project has been designed so that it only considers the ones towards the center of the screen and not the ones towards the side. Noticeable from the images, the red boxes here are different from the ones that is created as part of my project, where here the red boxes refer to predictions, and for my project, Python code is written to detect the ones which are close. So I have downloaded the SDK from the managed model as the car detector ARM32 version right there. And when I download it, it downloads the file and a link with which I can pip install the library into my Python 3.7 environment that I've just created. This Python module performs car detection and it uses the Pi camera, and it has a trigger point where it detects if a car is too close and plays a sound and colors a box. I attempted to install a pan tilt mechanism to the car, which would make the camera move along with faces, but the ordered device did not work. So I scraped it off, but that can be an extension for the application. Now, the camera, connected it with the Raspberry Pi right there, and there's an HDMI port that connects it to my cable. So we can see the output of the Raspberry Pi right there. And this Raspberry Pi right now is powered with my laptop right there. And here in my laptop, I am playing a random episode of Brooklyn Nine-Nine. And what we can see is that if I just turn on the camera responder, it will turn on and we will be able to see the camera. Now, if I'm just moving this to that direction, which is pointing to that, we can see that it performs face detection quite well. So we're designing the outer cover of the car, which is just made of cardboard, and this will just be placed on top of the car where the car would have access to the camera. The project involves the use of a lot of the things that are learned in this unit, including Sewn circuit, which I've used to create a sort of like a headlight as a decoration. And I've used the microbit and I've coded it such that it calculates the accelerometer. and a lot of the other things, including the creative parts of drawing, using paperboard to make the covering, finally to create an outlet to be used in a real car. In the Raspberry Pi out of the car, and I've attached it with a power bank, and it's in a box with the camera outlet outside.